Okay, let's look at this one. I'm not a big fan of this one, just to be clear, because again, there's two different ways to describe this in terms of transformations done to f of x to produce g of x. I think because it's more in line with the way we're going to graph, I'm going to rewrite g of x. So I'm going to write g of x to be this. I'm going to factor out the negative, whoops, excuse me, I forgot my base. I'm going to factor out that negative 5, and I get x plus 8 fifths. Okay? Yeah, that looks good. So for our description here, let's talk about that. There's really two things going on here. Now, the reason I don't like this, there's a couple reasons. One, I would have preferred them just to give f equals e to the x instead of e to the negative x. I would have liked you guys to have to describe the negative x, but we're not going to, that's fine. So in this case, what we really need to talk about is we're going to talk about that number and this number. They're both happening to the exponent, so they're both horizontal stuff. So let's start with the 5. The 5, because it's affecting the x, it's a horizontal. So I'm going to say f of x shrunk by 1/5. Okay? Then we're going to take care of that 8/5. That's a horizontal translation. So f of x translated left 8/5 units. Okay? So when we go to graph this, let's take care of a couple things here. First off, let's move our graph 8/5 to the left here. I think I might move this line here. So let's move that over a little bit. Let's go like this. Okay. So we are translating the origin 8/5 to the left. So see if you agree with me. This would be 1. 8/5 would be right about there. So I'm just going to make a point kind of, let's see, I'm trying to figure out how to do this. So 8/5 maybe is right about there, negative 8/5. Can't see that, right about there. Nope, I went over too much. Negative 8/5 is right about there. Okay, so in other words, if you were to draw a coordinate grid through there, it would look something like that. Okay, let's go and graph. So I'm going to treat, reminder, I'm treating this point right here, I'm treating it like the point 0, 0 for when I make my table. And so what I'm going to really do is I'm going to be graphing the function y equals e to the negative 5x, but I'm graphing it with the point indicated 0, 0. So let's go and do that. I'm going to, just because what I want you to do in this case, I want you to pretend that you were just given this and you were asked to graph it. Okay? Just pretend that that's what you were given. You were given that and you were asked to graph it. This right here, this didn't exist. Okay? So if that were the case, then really our parent function, the one that we're going to be making the table for, would be y equals e to the x. Okay, that's the most basic function. And the reason I say that is it's just easier. If we use that one, we've done those numbers a bunch of times. So I'm going to have my x, and then I'm going to have my parent. In this case, I'm going to have my y, and then because there's stuff going on horizontally, I am going to be multiplying my y's by negative 1/5. Sorry, I'm going to be multiplying my x's by negative 1/5. Hopefully you see why that is. Just to emphasize, that's the case because we shrunk it by 1/5. I'm going to put here, because I didn't say it, horizontally. Okay? That was important. So let's go make our table. So if for y equals e to the x, we've done that a bunch of times. So I'm just going to plug in my numbers, -1, 0, 1, 2. If I use those numbers, 0.37, 1, 2.7, and 7.4. Now remember what's happening. I'm going to take all my x values, so this column, and multiply them by -1/5. So I get 1/5, 0, -1/5, and 2/5, -2/5. So when I go to graph this, I'm going to be using those two columns. So let's go and do it. So I've got the point 1/5, 3.7, yuck. That's, or 0.37, sure. So I'm going to say, I'm going to kind of exaggerate this, say it's right there. Then I've got the point 0.1. So 0.1's right there. Excuse me, my brain just blew up there for a sec. Then I got the point -1, -1, what is it? 2.7. So, sorry, -1/5, 2.7. So maybe about there. And then the -2/5, 7.4, 1, 2, 3, 4, 5, 6, 7.4. So maybe about there. So the graph looks like this. Okay? Again, it's going to hug that horizontal asymptote. Okay. Not great, but that's fine. Let's keep on going. Let's do number 15. I'm going to see if I can fit 15 right here. I believe I can. So 15. This one's much better in terms of what they're asking us to do. And the reason being is the base function, the parent function is a nice parent function. So 1/2 log base 4x plus 5. Okay, let's talk about what's going on here. So first off, see if you agree. This is being multiplied to the whole function. So there is a vertical shrink by 1/2. Then we have to take care of this, and there's a translation left. So then translated left 5 units. Actually, I'm going to take that. I'm just going to move it a little bit. I'm going to move it up here. Oof, not great. Okay, I'm just trying to give myself a little extra room. Okay, let's see here. Let's go grab a coordinate grid. And let's graph. So the only thing I have to really worry about in this case, the first thing I have to do is worry about is that translation. So if the graph would be, it's normally here, I'm going to translate it 5 units to the left. So something like this. 1, 2, 3, 4, 5, something like this. Okay? So this would be my new coordinate grid. Quick reminder on how we do this. So I want to make a table for log base 4 of x, but that's rough. So what I'm going to do instead is I'm going to take its inverse. And its inverse is y equals 4dx. And I'm going to make a table for that. That's because that's pretty easy. So I'm going to x, y, I'm going to use -1, 0, 1, 2. Those are the only numbers I'm going to use there. Then let's go for our x value. So if I plug in -1, I get 1/4. I plug in 4, I plug in 0, I get 1. Plug in 1, I get 4. I plug in 2, I get 16. Okay? So for the inverse function, so when I go to take the inverse function, reminder, the inverse will be this. So let's go and do that. So I'm going to have my x, I'm going to have my y, and then I'm going to have that stretch. So we're taking this function, and shrinking it by 1/2. We're taking the y values and multiplying them by 1/2. So remember, we take the table, the y equals 4x table, and we flip the values. So this is going to go here, and this is going to go here. So in other words, it's going to go 1/4, 1, 4, 16, -1, 0, 1, 2. Now I'm going to take those y values and multiply them by -1/2. So -1/2, 0, 1/2, 2. Okay? Let's see what we got. Okay, this looks good. Okay, let's make our table. So remember, when we go to do this one, I'm going to use this column and this column. So I've got the point 1/4, -1/2. So that's maybe here. Then I've got the point 1, 0, which is there. Then I've got the point 4, 1, 2, 3, 4, 1/2, which is maybe there. 16/2 is obviously going off my thing. So I won't use that. Oh, it's not 16/2, is it? I multiplied it by 1/2. I don't know how I got that 16/2. That should be 1, 16/1. So my apologies. Hopefully that's okay with you. I took the y value, multiplied it by 1/2. So again, it's off my graph, but I'm going to aim for it. So my graph is going to look like this. So I'm aiming for kind of out there, right? So something like that. Okay? I'm going to stop this set right here.